Hello, this is John from caveofprogramming.com. In this tutorial, we're going to look at setting pixels in our bitmap. So we've already got a setPixel method stub that allows us to specify X and Y coordinates of our pixel. And there's 1 byte of information each for the red, green and blue values of that particular pixel. The first thing I'm going to do here is I'm going to get a pointer and point it at this particular pixel as specified by X and Y. So I'm going to create a uint8 underscore t star pointer, which I'll call p-pixel. Now I can't set that equal to m underscore p-pixels because m underscore p-pixels is a smart pointer. It's a unique pointer which can't be cast to an ordinary pointer. So if I try to build that, I get an error. But what I can do is I can use the get method of unique pointer to get a pointer to the underlying memory managed by this unique pointer. So now if I build it, it's fine. We've just got an unused variable warning. Now I've got a pointer to our whole memory block that represents the whole screen, and I want to move that to point at the correct pixel. So we can use pointer arithmetic. If I add the value 1 onto this pointer, that would move it forward by 1 byte because this is a byte type. So what I'm going to do is I'm going to say p-pixel plus equals, and I'm going to move it forward. Well, let's pretend initially that every pixel takes up just 1 byte of information. In that case, what I'd add to it would be y times m underscore width plus x. So y times m underscore width is the number of pixels or the number of bytes, if each pixel is 1 byte, in all the rows before the one that we're actually interested in, as specified by y. And once we get this to point at the right row, we then move it forward the number of columns specified by x, and then it's pointing at the right pixel. But in our case, because we've got each pixel taking up 3 bytes, we have to multiply x and y by 3. And I'll use brackets here. They're not needed because multiplication has a higher precedence than addition. So this would work fine without the brackets, but I'll put them in to make it a bit clearer. Now we've got a pointer that points at the right location for this particular pixel in our memory. And now I can use the array subscript operators to reference the red, green and blue bytes following the one that this actually points at. So let's say p-pixel 0, and that's actually going to be equal to our blue value, which I'll explain in a second. And first I'm just going to copy that and I'm going to paste it in, and this is going to be red and this is going to be green. The reason why they are in the reverse order is because the bitmap is a little endian file format. Let's just build this to get rid of that warning. So if you imagine you've got some number, in fact in hexadecimal, we could write out our sort of values like this. Let's have FF for red, 88 for green, and 44 for blue. So it's just a hexadecimal number. Hexadecimal is useful because this would take up exactly 3 bytes with 2 digits for each number. If you don't know hex, don't worry about it too much. But you could ask which is the least significant byte and which is the most significant. This is the least significant because changing that has the smallest effect on the overall number, and that's the most significant, which has the biggest effect on the number. So it's the same in decimal. If we write some number in decimal, changing the 7 has the least effect on the value of this. Changing this 8 here would have the biggest effects. It's multiplying, I don't know what it is, like thousands of millions or something. Now in the little endian format, you store the least significant byte in the area of memory that has the smallest memory address. So if you think of the memory as being laid out from left to right, like this means that we will be storing this bit of this number or this bit of this number over here in the smallest memory address, and this bit or this bit will be stored over here in the biggest memory address. So in effect, it's reversed from a normal point of view. So if we think of the red, green, blue triplet as a single number, then we end up basically reversing the red, green and blue values within this number when we specify it in memory. So this actually is going to be 1 and this is going to be 2. Sorry if that, apologies if that confused you. I meant to fill in these indices. So the 0th bit here is going to be blue, and then we're going to have green, and then we're going to have red in reverse order, because the bitmap is a little endian format. It's a little endian file format. Now let's go to main.cpp and try to use those values. So we must do this before write. It's not going to work if we do it after write. Let's say bitmap.set pixel, and I'm going to create a couple of constants here. So I'm going to say int width, and I'll put it in uppercase because it's a constant, equals 800. And the reason I'm doing this is because I'm going to have to refer to these values multiple times, and I don't want to have to retype them over and over again. That's just really bad practice. I want them all in one place so that I can change them just by changing those 2 lines when I want to. So now we can say width and height. Let's first try setting the pixel right in the center of the screen. So that's going to be at width divided by 2, half the width, half the height, and I'll set it to white. So 255. So each of the color values ranges from 0 to 255, which is what you can fit in an unsigned byte type. And that should set a white pixel in the middle of my bitmap. Let's build it. And if there are no errors, we'll run it. And we need to make sure that we get this finished coming out before we try to access the bitmap. If it doesn't appear, there's something wrong with your program, or you could just try building it again. But you've got to see that, so that you know the write happened before you actually look at the bitmap. Let's take a look at it now. So here's the pixel set in the middle. I don't know if you can see that. Let's zoom in a bit. So there it is, right in the middle of my bitmap. We've got a white pixel. Now, one interesting thing to note about the bitmap format is that it numbers y from the bottom, 0 from the bottom, and y has its maximum value at the top, and x is 0 at the left and has its maximum value at the right. So if we made y, for example, 100, which is less than half of the height, then we will see the pixel is set lower down the screen, lower down the bitmap. So there it is, it's kind of near the bottom now of the bitmap. Now I'm going to give you a little challenge, which is see if you can make the entire bitmap red. And you can stop the video if you want to and have a go at that. And I'm going to show you how to do it here. So to actually do that, as I say, have a go at this first yourself if you want to before watching this. But I'm going to use a loop, and I'm going to say for int y equals 0, and keep going as long as y is less than the height, y plus plus. Still not very fluent with this new keyboard I've got. I'm just going to copy that and paste it inside to save me some typing, and then I've got to change this to x, whoops, that's x, this is x, and now we need x to range from 0 to 1 less than the width. Just format that. Now we can take this bitmap.set pixel, move it in here, get rid of that extra line, and let's set green to 0, blue to 0, and we'll have red at maximum. So if I run this now and we take a look, we should have a red bitmap. Let's just check. So it did finish. Have I done something really stupid? Yes, I have. I forgot to put X and Y in here. There we go. So the whole point of that is we can set each pixel one after the other. Let's try this now. Hopefully that will work. Let's run it and have a look. And still not working. What did I do wrong? There's got to be a mistake in here somewhere. Yes, there's a very, very stupid mistake in here, and I could redo this video, but I'm not going to, just in case you do this, because I've already done this like twice and it's driving me crazy. There's a mistake right here. So if you want another bit of a challenge, stop the video and try to figure out what it is. And now I'm going to tell you. It is that I did the right before I set the pixels exactly like I think I just told you not to do. Okay, we've got to do the right. We've got to set the pixels and then do the right. It's like twisted in my brain somehow, but let's run this, and now it works. I swear this works. There we go. We've got a nice big red bitmap. Okay, so that's it for this tutorial at last. Quite a lot of information there, but if you can get this working, then that's basically the whole point of the tutorial. You know, you can give yourself a pat on the back, I reckon, if you can get it working. Okay, and we'll move on to maybe creating a fractal class in the next tutorial. So until next time, happy coding.